In today's class, we are going to discuss with respect to the topic called as balanced data set and imbalanced data set. Balanced data set versus imbalanced data set. What is called as balanced data set? What is called as imbalanced data set? Okay. So this concept of balanced and imbalanced data set concept is applicable only for the classification problem. Okay, this is applicable only for classification related problem. That is point number 1. Okay, now where the classification is, output variable is discrete. Discrete categorical data or discrete categories. We are having discrete categories in the output variable. We are having certain categories are there. Now, if in the output variable, if the output variable has if the output variable has okay if the output variable has equal number of records of each category then it is called as balanced data. Then it is called as balanced data. Otherwise, it is called as imbalanced data set. Right? For example, in the output variable, we are having two categories, that is yes and no's. We are having yes of 400 records and no's of just 100 records only. Then it is called as imbalanced data. So what we are going to do, just we are going to check whatever the output variable is there, df of that particular output variable, whatever the output variable is there, that output variable dot value counts. We are going to see the value counts of the output variable. If whatever the category 1 and category 2, the number of counts of category 1 and number of counts of category 2 both are equal, it is called as balanced data set. If both of them are not equal, then it is called as imbalanced data set. If we are working on the imbalanced data set, we may get whatever the data we are giving to the algorithm, we may get less accuracy. In order to improve the accuracy, we have to give the balanced one. So till what it is called as balanced. So whatever the ratio of category 1 and category 2, if the ratio is up to 75% also, we can call it as balanced. Okay. If the ratio is 75%, okay, fine. Means we are having with respect to category 1 of 750 records, category 2 of 1000 records are there. Okay, consider, not a problem. Okay, if you multiply with the 0.75, you are getting this one, right? So not a problem. So up to 75% or 70%, it is okay. Whatever the train size we are considering, up to 70, 80, minimum is 70. Than that, it is less than 70 means surely it is called as imbalance only. Okay. For example, category 1, you are having 700 records. Category 2, you are having 1000 records. Fine, not a problem. Still, it is considered as a balanced only. No problem. If you apply the machine learning algorithm also, it will give the good result only. But for example, you are having one kind of data set available. So like your Hartstock prediction, which we have used for discretization technique. Do you remember that one? In that, we are having 43,400 records are there. Out of which so let us take this. So already we have completed this particular data set. I'm considering only this data set. So out of this data set has total 43,400 records, out of which 42,617 records are of one class, whereas just 783 of one class. This is highly imbalanced data set. If you give this particular data set, this is also a classification algorithm only, where we are having in the output variable, the classes, whether the person will get a Hartstock or not, right? So for this data set, whether we get a Hartstock or not, we want to predict something like this. Then if you are working for this data set, one class is of 42,617 records, one class is of just 783 records. Means within this is just 20% of the data. 80% of this out of, if you calculate the ratio, whatever the ratio you are having, 783 divided by 43,400 records. If you calculate this percentage, okay, just this is of into 100. If you multiply into 100, just it is of 1.8% of the given data, right? Just it is 1.8% of the given data, means approximately 2% of the data. Out of 43,400 records into 2%, that is 0.02, you are getting with respect to, for 2% of the data only, we are getting of 868 records, means it is less than 2%. 98% of the data is one category, just 2% is one category. Right? Now, in this case, it is called as imbalanced data set. Now, if it is imbalanced data set, now if you take this particular data set and if you apply the machine learning algorithm by considering this one as your output variable and remaining as the input features, then the accuracy will be comparatively very low when compared to a normal balanced data set. Now, in this case, what we have to do? How to balance the data? Now, in this, we are having different options. Option number 1 is called as undersampling the majority class is the option number 1. Example, for example, one of the categories is having 99,000 records, another one is having just 1,000 records. It is an imbalanced one. Means, for example, if you multiply with this one, whatever the higher value is there, into 0.7, just multiply. Whatever the higher value is there, out of these two, one will be higher, right? Whatever the higher value is there, that 99,000 into 0.7, just multiply like this. 99,000 into 0.7. Okay, if you are getting other one more than these many records, okay, balance. Out of 2, 1 will be high. For that high one, just multiply 0.7. More than 0.7 other records are available, means okay. Means 69,300 other records are there, means fine data set. That is considered as a balanced one. But less than 69,300 are there, means then it is considered as imbalanced one. Now, whenever you are having an imbalanced data set, then we have to do the balancing. And then only we have to divide the data. This one has to be done before train test split only. These things has to be done before train test split. Okay. Now, here, whatever the data I'm having, out of the majority class, I'm going to consider 1,000 records of the majority class, and minority class, whatever I'm having, 1,000 records. Whichever the data is having more number of records, that is called as majority class. That is called as majority class. Whichever the data is having less number of records, that is considered as minority class. Okay. From majority class, just select randomly 1,000 records. Whatever the minority class number of records are there, just select 1,000 records from this sample. And now use these 1,000 and this 1,000. Overall 2,000 records you use for your modeling. Don't use total 1 lakh records. Okay. For example, the original data is having overall 1 lakh records. Original data has overall 1 lakh records. Forget about the Y. Okay, forget about the number of features, input features, forget about the columns, records. 1,000 records are there. Out of these 1,000 records, Y variable we are having with respect to yes and no's. This generally happens in the finance related companies. For example, we want to predict a loan. How many number of people will default the loan and how many of them will repay the loan, means in the real life, 90% of the people will repay their loan. 10% of the people will default their loan. Default means they'll not repay the loan. But these 10% of the people, whatever the main amount they are considering, that one also is a loss for the company. Okay. So now here we are having, let us assume in this case, I'm having 90,000 records of one category, 10,000 records of one category. Okay. 90% of the data is saying that they'll repay the loan. 10,000 records says that they will not repay the loan. Like this, I'm having the data set where the output variable has with respect 90,000 of one class. One class is repay, that is called as non-default, or which is also called as 0. Okay, if you do the encoding, it is 0. Here it is who will not repay, which are nothing but called as defaulters. Not repaying are called as defaulters. Who will not repay their loan is called as defaulters, and they are considered as 1 in the data set. Now I am having in my original data, zeros are 99,000 are zeros are there, ones are just 1000 are there. Now what I'm going to do from this 99,000, randomly I'm going to choose 1000 records. Randomly I'm going to choose 1000 records from this data, and here I'm having 1000. Now overall I'm having only 2000 records. For these 2000 records, I'm going to divide the data into 80% for training purpose, 20% for testing purpose. Now 1600 records I'm using for training the machine, and 400 records I'm using for testing the machine. Now there is a high probability you'll get when you apply directly this one, 1 lakh records if you use for 80% for your training and 20%, that is 80,000 and 20,000. If you consider this one, now in this case, what happens means there is a high probability it is one-sided. For example, you are collecting 80,000 records for your training purpose. Means out of 1 lakh, 80,000 you are using for training purpose. Now in this 80,000, assume that 60,000 of the data is with 0 only. 20,000 only of zeros with ones are there in the training data set. There might be chance like this. There might be even chance of 75,000 records of 0 with only 5,000 of ones also possible. So when we are training with more number of zeros, the machine was trained 0, 0, 0, 0, right? That it was trained. Automatically, the real person also will assume that he is a non-defaulter only, because it is having the overfitting problem. So in order to reduce that one, now what we are going to do is we are trying to reduce to this one like this. This is called as balancing. Okay, balanced data set. So in order to make the balanced, we are going to use the undersampling of the majority class. So from the majority class, we are going to select only 1000 records. From the minority class, I'm going to select 1000 records, and then I'm going to use for the modeling. That is X train, Y train. Everything is common. Instead of considering 1 lakh records, consider only 2000 records. If, sir, as the data decreases, automatically correctness will not be there, right? If you consider this 1 lakh records, try first time with 1 lakh records. Don't apply the undersampling. Don't apply the undersampling. First you apply the 1 lakh records and go and apply the logistic regression. Okay. Now after that, consider these 2000 records. Now you apply the same logistic regression. This time you will get better accuracy in this comparatively, because it is a balanced one. Right? Now, next, this is one option. Option number 2. If you are having 99,000 records of majority class, minority class of 1000 records. Now option number 2 is oversampling of minority class by duplication. Means the same 1000 records you have to multiply 99 times. 1000 records directly you have to multiply 1000 times. I mean, for 99 times. So 99 times you have to duplicate the same data. Repeat the same data 99 times. So now 99,000, 99,000 and create the model. Where this is completely duplication. But which is a wrong one. We should not do. Generally the duplicates will remove. Here we are creating the duplicates, which is a wrong one. Generally we should not do. Sir, since this one we should not do, then I want to do the oversampling. Then what I have to do is, the second option of oversampling is not, instead of creating the duplicate records, we are going to create the oversampling only by using the smart technique. Now what is meant by smart technique means, it is going to generate the synthetic data. Okay, it is going to create the data. Synthetic data it is going to create. Sir, how it is going to create? For example, I am having with respect to the values like this. Some records I am having. Okay, here 1, 0, 4.2, 9.8, as this is there. Assume. If you repeat the same thing, it is called as duplicate. If you repeat the same thing, the whatever the 1, 0, 4.2, 9.8 is there, as this if you repeat in the second record, then it is called as duplicated one. For example, this is 4.3. Then it is not called as duplicated one. So like this, we are going to create the synthetic data. How this synthetic data will be created means based on the k nearest neighbors. It is for each and every record, it will identify the nearest neighbors of five values. And if it is a discrete data, it will apply the mode. If it is a continuous variable, it will apply the average value. And it will create the new record. In that way, we are going to create the new records, which we used to call as smart technique. Smart means synthetic minority oversampling technique. S stands for synthetic minority oversampling technique with respect, which is called as SMART, right? So again, you are going to do the oversampling only. One is undersampling, one is oversampling. In the oversampling, one way of oversampling is duplication. One way of oversampling is SMART technique, where it is going to apply the KNN algorithm and creates the synthetic data. Okay, assume that, for example, here whatever I have shown you earlier, take the same thing. Okay, here I am having with respect to 5 records are there. If these 5 records, if I make any one of the record as is, then it is called as duplicate. Now I am not going to make it as duplicate. Now I am going to create the 6th record using these 5 records. Assume these are the 5 nearest neighbors. Now out of these 5, which one is most repeated one? Male. So this is going to create male. Here 5 records. These are the nearest 5 values. Out of these 5 values, what is the average value of this one? It is going to create. This is a discrete count data. So it is applying the mode 0. This is a discrete data mode. It is a discrete data. Yes. It is a discrete data private. This is a discrete data rural. This is a continuous label. So average. It is going to take the average. Okay. And next BMI. BMI is a continuous variable. So it is going to take an average. Smoking status. It is a discrete variable. So it is applying the mode. And finally output variable. Again, it is a discrete variable mode. So like this, it is going to apply the synthetic data by identifying the nearest 5 neighbors. First, it will identify the nearest 5 neighbors. For that, it will apply that one. That logic is applied for the nearest 5 neighbors. Right? In the backend, just it is applying the KNN algorithm. Using the KNN algorithm, it is applying the synthetic data. Now, this whatever undersampling technique or oversampling technique we are having, these are applicable for logistic regression. If you are working on the logistic regression, we have to make the balanced one. If you are working on the KNN, we have to apply the balanced one. If you are working on SVM also, we have to make initially the data as the balanced one. If you are working on the decision tree also, we have to make the balanced one. But if you are working on the random forest or ADA boost or gradient boost or XGBoost, no need of doing the balancing. Because these all the records are selected based on the random sample. Already they are random only. So there is no problem for that. For these assemble algorithms, we no need to do the balancing. We have to do the balancing only for the single algorithms. If you are working on the single algorithm, for that data, we have to do the balancing. If you do the balancing for this same data also, the result will not change. Mostly the result will be almost same. Maybe minute changes of 1 or 2% might be changes, but most of the cases it will be the same. But here you can see the much variation. The difference you can clearly observe in this. In this, you can't observe the much difference. That is the fourth option, that is called as assemble method. Assemble method is where instead of here I'm having like this the imbalanced data. What I'm going to do is first I will take part of the data, sample of the data, 1000 records I will select and I will make the first model. Again 1000 records I will take and second model. Third record of 1000 records, third model. And finally I will take the majority vote, which is nothing but your random forest. Similar in the random forest also it is going to select subset of data only, right? Randomly it is going to choose the subset of the data. So random forest model or with respect to gradient boost, XGBoost or ADA boost. ADA boost also comes under the same because the tree was pruned. Complete data you have not considered. Gradient boost also tree was pruned. Complete data was not considered. In the XGBoost also the tree was pruned. Complete tree was not considered. Complete data was not considered. So those assemble algorithms, we no need to do the imbalancing. So imbalance no need to be converted to balance. For a normal single algorithms, we have to do this one. Okay. Now the coding part, let us get into the coding part of this. For this balancing, the coding part. So I'm going to load the data set. One data set randomly I have selected. I have taken some random values. I have created the dummy data set. Okay. So here I'm having with respect to the X variable and Y variable. And the whatever the Y variable is there, for the Y variable, I'm applying the value counts. Okay. the version total I have taken this one, this particular data, whatever the data set I have considered is 1000 records. Randomly I have chosen. Just in the backend, I have written the np.random.sample. Random and using the random module, I have created randomly some sample, some values. Right? Now here I am having overall 1000 records are there. Out of 1000 records, y variable, the output variable y is there, right? This particular variable is having 900 ones are there, 100 only zeros are there, which is a imbalanced one. Okay. Now for this, to make the balanced one, we are going to use undersampling of majority class or oversampling of the minority class with respect to duplication or with respect to smart technique. So first, undersampling of the majority class. How to do the undersampling means, first we have to work on the library called as imburn, where it is a IMB stands for imbalance, learn means learning. Right? Now first you have to install this particular library. From this library, we are going to import the undersampling, where random undersampler is the function. So we are going to take this random undersampler function as is equal to rs, and I'm going to fit underscore resample of x comma y, means entire data of x comma y, 1000 records I'm giving, and I'm asking to fit on undersampler, means consider one of them, whichever is having the lower class out of x and y. This is having 900 records. This is having 100 records, out of which one of them will be low. So if it is low, 100 records is low, means from the x you select randomly 100. For example, y is you are having 200, means select randomly 200 from x. If y is equal to 300 are there, means from randomly you select 300. Automatically it will only calculate that one. How many values of y are there, and according to that it is going to select from the x. Right? So it is going to take like that random undersampler function. Now if we see this x comma y, now x comma y, we are having 1000 records. Now using this x comma y, we are going to do the next step called as train test split. We are going to apply the x train y train, whatever the x train, okay, x train comma x test comma y train y underscore train comma y underscore test, okay, is equal to, okay, is equal to train test split. You are going to apply train test split. Okay, this train test split, instead of considering the original x and y, you are now considering this one, x new and y new. After resampling, now whatever the data is there, this values you consider. Now you are having overall 200 records only, not 1000 records. Only 200 records are there. So now not even 200, 100 records only is there. 100 records only is there. That is where we are having with respect to the category of, 200 records. 0 category of 100 and y category of 1 with respect to 100. 200 records are there. Now using these 200 records only it is going to have. So if you want, you can even check the shape. What is the shape? Okay, dot shape. If you ask the shape, you can see what is the shape. $200 records, right? So 200 records you are having. These 200 records only we are going to split, and you are going to take the test size and random state common. Instead of going with x comma y, we have to do this sampling and then we have to apply this one inside. That is the only difference. Okay. This concept we have to apply only if it is an imbalanced data set. If it is a balanced data set, you don't need to apply this concept for that. Is that clear? So this one has to be applied before the train test split. This should be done before train test split. Right? Now, this is option number 1, where random undersampler is the option number 1. Option number 2 is using near miss. One more function is there, near miss. Okay, this one also you can select. Both are same. Above and below both are same. One they have created using the random undersampler. One they have created using the near miss. In some textbooks, near miss they have used. In some textbooks, this they have used. Okay, any one you can remember as per your choice. Right? Now, oversampling of the minority class by duplication. If you want to duplicate, Now we are using the random oversampler is the function. Random undersampler function is for this. Here random oversampler is this one. Now here I'm going to use the random oversampler and I'm going to fit on the x prime, sorry, x and y. Now I'm going to get 900, 900. Okay. So one class is of original data has 900, right? So it is duplicating the second one. Zeros also 900 records. So now 0 also has converted to 900 records. The 1 will be asterisk. 0 will be converted to 900, means multiplied with 9. Okay. 9 times the same data set was considered. Right? Now, next one is oversampling of minority class by applying the SMART technique. Generally, we should not go with this one. Okay. In the interview, they'll ask you if there is an imbalanced data set, how you are going to work on the imbalanced data sets. So you have to say either using an either using the undersampler or by using the oversampling. So immediately they'll ask what is meant by oversampling. Oversampling means if you say with respect to duplication, immediately there is a high probability you will get rejected, right? Because generally in the data cleaning will drop the duplicates. Because that is not the good data, bad data. Bad data will generally remove. You are only creating the bad data, miss. It is not correct, right? So that is the reason we should not create the duplicates. We have to create by using the SMART technique. So you have to say the second option of oversampling is by using the SMART. How this SMART will work is based on the KNN algorithm. By using the KNN. In the backend, KNN algorithm will be used and it is going to balance the one. Once again, zeros will be taken into 100. 900. So zeros are originally 100. Now it is 900. But this time synthetic data, not with respect to doing the duplication. Is that clear? So these are the three different options and commonly assemble algorithm. Okay. Yeah. That is the syntax to install any particular library. If you want to install any particular library, that is the syntax. Okay. Pip install imburn. Right? Is that clear, guys? I have written the print hyphen like this in order to visible clearly. Nothing else. Print of hyphens means it will print as this. Whatever is there inside that it will print. Right? Done? Is that clear, guys? Explain once again. Which part? Shambhunath. Which part you want? Shambhunath, can you type your question? Which part you want? Data. What data? Train data. So here, whatever you are going to use for training purpose, after doing the sampling, see, before doing the imbalancing, assume there is total 1000 records, out of which 900 of one class and 100 of one class. This is the original data they have given to us. Okay, forget about today's class. I have not discussed assume. Now what generally you will do? Out of 1000 records, you are going to use 80% for training purpose, 20% for your testing purpose. Generally, you will do this one and you will predict on the X train, you will predict on X test and you will calculate the train accuracy, test accuracy, cross validation score. Whatever it is there, you will do that generally. Now, here total 1000 records 80-20 ratio can be applied if it is balanced one. If it is an imbalanced one, we can't apply this logic for logistic regression or SPM or for decision trees. So whenever the 1000 records they have given like this for imbalanced data set, first we have to do the balancing. After that, we have to do the train test split. So for balancing, out of these 1000 records, out of which 100 records, if for example, undersampling I am considering, undersampling 100 and 100 means now only 200 records you are having. Remaining 800 records you are removing. You are not going to use. Out of this 100 records you are using the 100 records of this one. Total 200 only you are going to use. 200 records you are going to use. Out of these 200 records, you are going to apply now 0.8 and 0.2 and you are going to continue the concept. right? Is that clear? Sir, if you want to do the cleaning and remove the outliers, then we have to do this. After cleaning, after wrangling, everything is that one, then you have to select this. So 95% of the data we have to consider, you said na? Yes, we have to consider 95% of the data, balanced data. 95% of the original balanced data we have to consider. For imbalanced data set, that concept will not be applicable. Or, okay, let us consider in your case only. Whatever you are saying only correct. Okay, let us consider in that case. 100% of the data is assume 1000 records. Okay. Out of 1000 records, I am having with respect to 900 records of this one and 100 records of this one in the original. Now, if I am oversampling, I am increasing the data or decreasing the data? By using the smart technique, I am increasing or decreasing? Now I am increasing, right? I'm not using 95% of the data. As you said, 95% of the data we have to use. Now I'm increasing the data only. Right? Now total instead of 1000 records, now I'm going with 1800 records. I'm increasing the data. That too, by using the smart technique, there is no duplication also is there. Duplicates are not there. At the same time, records has been increased. Is that clear? Done? Now, that is how to handle the imbalanced data set. Next topic is future dimension reduction. Next one is called as dimension reduction. Dimension reduction means dimensions are nothing but futures. You are going to reduce the futures reduction. Okay, you are going to reduce the number of futures. Dimensions means nothing but called as number of futures. Okay, so number of futures we are going to reduce, right? So dimension reduction can be done. Whatever the dimension reduction is there, this can be done in two ways. Dimension reduction can be done in the two ways. Now, what is meant by dimension reduction means reducing the number of futures. What futures? Input futures. Output future we can't reduce. We should not touch the output future. Reducing the number of input futures. Okay. Reducing the number of input futures is called as dimension reduction. Reducing the number of input futures. Okay. Reducing the number of input futures is called as dimension reduction. Now, which futures you are going to reduce? You can't delete the important variables, right? At the same time, we should not remove more than 5% of the data unless it is statistically proved. If you prove statistically, then you can remove whatever the data you want. Even 80% of the data also you can remove if it is statistically proved. Okay. Otherwise, you can remove up to 5% of the data only. Right? Now, here dimension reduction can be done in the two ways. Now, for this understanding this concept very clearly, I'm going to take a simple example. Okay, there is a company. In that company, one team is there. That team is consisting of total 5 members are there. 1, 2, 3, 4, 5. Okay, first person is very good at core Python. He is basically very good at core Python. Second person is very good at Python for Python libraries. He is very good. Third person is very good on the statistics part. Fourth person is very good on the EDA part or analytics, data analyst. He is basically a data analyst. Okay. And fifth person is very good at machine learning. I am having 5 persons like this in my company. Out of which for 5 persons, we are paying monthly a salary of overall. Out of overall 5 persons, we are paying, let us assume it is around 40 lakhs. Okay. Now I'm not having that much of budget with me. Okay. So 40 lakhs from next month onwards, I can't pay for 5 members 40 lakhs salary. Okay. Sorry, this is per annum. Per annum 40 lakhs, not per month. Per annum 40 lakhs. Out of 40 lakhs, I can't bear with respect to 40 lakhs. I want to reduce myself to 35 lakhs or 32 lakhs, whatever it is, I want to reduce. So Here I want to remove one person. Directly, I'm going to remove one of the person. For example, this person I don't want. Directly, I'm removing this person is called as future selection. Future selection means removing that particular future. Remove the future which is unimportant. Comparatively, which is unimportant, remove the future which is unimportant. Is called as future selection. Directly remove that particular variable or particular future. Here the 5% are nothing but a data set consists of 5 columns, 5 input columns, that is x1, x2, x3, x4, x5. Remove whichever is unimportant, remove one of them. Out of 5, one will be unimportant, right? That you remove. This is one option. Okay. Now, what is the second option? But he is very good at core Python, right? Now, if I remove some Python work, who will do? So what I'm going to do is, I'm going to ask this person to share his knowledge to the others. If I ask directly, why he will share? So indirectly, we have to ask. Indirectly, how we can ask? By conducting some kind of meetings or some kind of webinars or something like this. And they'll have a discussion and we'll ask this person to share his knowledge. Now, this person will share his knowledge. Now, after sharing his knowledge, now whatever this person can do, these remaining 4 members can do that work. Now, this person we are going to remove. Miss, what is this called as? Use and throw. Okay, we are going to use that person. We are asking that that person to share his entire knowledge to others. Now, we are going to throw that person. Now, you are not, you are waste for us. Use and throw. This is called as future extraction method in machine learning. One is called as future selection, directly removing. One is called as future extraction, extracting the important things and after that leaving. Is that clear? So we are having 2 options. One is called as future selection. One is called as future extraction. Right? Both of them will reduce the number of dimensions. In both the cases, dimensions, number of input features will be reduced. Right? Now, for example purpose only, don't again ask, sir, ethically it is not correct. No need to discuss that much of detail about that one. Example for understanding purpose only. Okay. Now, we are having with respect to the first option called as future selection, where we are going to identify unimportant variables, identify the unimportant variables and drop them. How we are going to identify their unimportant variables? How we are going to identify their unimportant variables? We are having different techniques are there, out of which the first one is called as filter method. Second one is called as wrapper method. Third one is called as embedded method. Okay. So filter method, wrapper method and embedded method. Already you have completed this one, everything. Right? Just you don't know the names. That's it. Now I'm going to explain. Now filter method means identify the unimportant variables and drop them using the filter methods. What are the filter methods means? For example, from the top to bottom, all the records are unique. Example, name of the student. What is the use of the name of the student in predicting the output variable? Name of the applicant, and is there any relation with the loan process? And that to person, everything is different. Every record is unique. There is no common thing is there. If there is no common thing, then how you can identify the pattern between them? So nothing common is there means just you can drop them. That particular variable you are going to drop, which is completely from top to bottom unique. That one we are going to drop. Right? If there is a common thing is there, for example, male, female, something is there means, then we can identify how many males are there, how many females are there. But name of the person means how everything are unique, right? Everything are single, only one is there. That too unique only is there. So that will be dropped. Whichever is unique, that will be dropped. Now, whichever is having low correlation with the output variable, statistically it is proved. It is not having any correlation. If it is not having any correlation, we are going to drop. Low correlation, that is, we are going to take either negative or positive. Direction is not important. We want with respect to correlation value is less than 0.2, very less, just 20% they are correlated, or 10% only they are correlated. With low correlation values, just we are going to drop. Right? Next, low variance. If any particular column is having very low variance, for example, here we are having with respect to height of the student, 5.2, 5.2, 5.2, 5.3, 5.2, 5.4, something. I'm having data set like this, assume. If you consider that height also okay, if you don't consider also not okay, because there is no much variation between them. So if you calculate the variance is very low means there is no difference. For example, gender is there. Male. Everything are male only. Means everything are 1. What is the variance? What is the variance for this? Equal to 0. There is no variance, right? No change is there. No change is there means if you consider also the same answer, if you don't consider also the same thing. Obviously, it is male only, right? So if there is no changes, means the variance is very low, that particular column we are going to drop. These are called as filter methods. Sir, variance, you told that we have to apply only for discrete variable, right? Variance cannot be applied for the continuous, variance should be applied only for continuous variable. Variance is applied only for continuous variable. We can't apply for the discrete variable. We should not go with the discrete variable, because in order to calculate the variance, first we have to calculate the mean. How we can calculate the mean for the discrete variable? So we can't calculate the mean. So we can't calculate the variance. We can't calculate the standard deviation. All these things we can't apply for the discrete variable. Then variance is applicable for continuous variable. For discrete variables, which are unimportant discrete variables, how we can identify means whichever is having the low information gain. You know already information gain, right? I already explained you what is meant by information gain, right? You are going to calculate for each column what is the information gain. If the information gain of that particular column is very low, that particular column you are going to drop. Whichever is having the low information gain, that particular column you are going to drop. Right? And by using the chi-square test or one proportion test for single column, if you are having only one single column, which type of test we have to apply? Hypothesis test, one proportion test. So if you apply the one proportion test, and if in the one proportion test, it says that it is less than 0.05, automatically that particular column is waste column. We can remove with respect to by using that one also. So by seeing the unique values, low correlation, low variance with respect to this information gain or one proportion test. By using all of them, we can drop the unimportant variables. You know what is meant by unique. You know what is meant by correlation. Correlation is relation between the input variable versus output variable. If there is no relation is there, there is no use of predicting. So that particular variable we are going to drop. You know what is meant by variance. If variance is low means there is no change. If variance is equal, so for example, I'm having a continuous variable of 4, 4, 4, 4, 4. Can you calculate the variance? What is the average value? Average value also 4 only. For each and every record, minus 4 means 0 only. That is x minus x bar whole square. If you do 0 square only, 0 only you will get. Variance is 0 means there is no change. If there is no change, if this value is there also, okay. If this value is not there also, same. Right? So whichever is having the low variance, that particular column we are going to drop. So these are all comes under with respect to filter methods. Okay. Actually, after future engineering, I have to explain this future selection. Why I have not explained there? Because you don't know what is information gain. After decision tree only, you came to know what is information gain. So that is the reason now I am explaining this one. Okay. If I explain before itself, before the starting of the classification algorithms or before the starting of the machine learning algorithms of how I have explained the data cleaning and data wrangling, if there itself, if I explain the feature selection, you don't know what is meant by information gain. Remaining everything you know, but you don't know what is information gain. This is reason number one, why I have not explained. Now, what is embedded methods means after modeling. These filter methods are applied before modeling. Before modeling, you have to do all these things. Before modeling, that too before train test split only. Before train test split only, you have to remove the unimportant variables. Right? Now, whereas embedded methods, this will be done after modeling. The model will tell you which are the important parameters. Like in the decision tree, we have got dot future underscore importances, random forest dot future underscore importances, ADA boost, gradient boost, exit boost. We have seen, right? Model has given the important features, that is called as embedded methods. Model has told you that it is an unimportant feature. Model has told you that particular feature importance is equal to 0. Importance is equal to 0 means it is an important variable, and we have dropped that one. I have shown you in the ADA boost. After dropping again, I have rebuilt the model also in the ADA boost. Do you remember? Okay, don't worry. Again, you will get back that one. That slide you will get back. So one of the quotient is 0 means that particular variable is you have to drop. For which variable the quotient is becoming 0, that variable you have to drop. Right? So the model, after the model only, that is decision trees, random forest, ADA boost, gradient boost, and exit boost, along with the lasso, these comes under embedded methods. Embedded methods means identifying the important features after the modeling is called as embedded methods. Before the modeling itself, it is called as filter methods. You are applying the filter. Filter means condition, some condition. And based on the condition which are not satisfying, you are removing those things. Now, one of the student has asked in the chat box that, sir, low correlation. You told that there should be low correlation. Between independent variables, the low correlation should be there. Otherwise, it is called as collinearity problem. Correlation between independent versus output variable should be high or low? It should be high. The relation between input versus output should be high. The relation between input versus input should be low. If the relation between input versus input is high, means it is called as collinearity problem. Right? Is that clear? If you have forgot the lasso or if you have forgot these concepts, means I told you everything are connected to each other. Now in today's class, if I am explaining the future selection now, you can understand because already lasso was completed, all the models, other models also completed, information gain is completed, everything are completed. Now you can easily able to understand this concept. If I explain this one before the modeling itself, generally future selection has to be done before modeling. But if before the modeling itself, if I explain, then how I can explain this embedded method at that time? That is the reason I am explaining this one now. Right? If you want to apply the embedded methods, means you have to apply after the model. If you want to apply the filter methods, means you have to apply before the model. Now, in between wrapper methods are there. Okay, next one is wrapper methods. So now wrapper embedded methods, where for filter methods, we are going to apply for continuous variable correlation coefficient or variance and mean absolute difference. That difference is very low. For discrete variable information gain or chi-square test, or chi-square test is nothing but inside the chi-square test, if you give one proportion, means one proportion test, both are same. If you give me 2 miss, it is 2 proportion test. If you give more than 2 miss, it is chi-square test automatically. Okay, chi-square test and 1 proportion test, both are same. Inside that, if you give 1 variable only, if 1 column only, if you insert that, it is equal, both are same only. If you give more than 2 variables only, if you give exactly 2 variables, it is called as 2 proportion test. If it is more than 2 variables only, it is called as chi-square test. Okay. Basically, one sample test, your one sample test is there, right? Your one sample test is equal to your ANOVA test. Your 2 sample test is also equal to ANOVA test. Inside the ANOVA, if you give only 1 sample, both are same. Inside the ANOVA, if you give 2 samples, it is equal to 2 sample test. If there are more than 2 samples, then it is purely ANOVA test. Okay. Inside the ANOVA, if you write only 2 samples, it is equal to 2 sample test only. Basically, both are same. If you want, you can try. What are the hypothesis testing we have done? Inside that, take the ANOVA test directly and apply only 2 variables inside that. Instead of going with 2 sample, you will get the same answer. But generally, for 1 sample, we'll go with 1 sample test. For 2 samples, we'll go with 2 sample test. For more than 2 samples, we'll go with ANOVA test. Similarly, for discrete variable also, chi-square test is equal to 1 proportion test. Both are same. Both are same. When? If you are working only on one particular column. If you are considering only one column, both are same. If you are considering 2 columns, both are not same. If you are considering more than 2 columns, means both are not same. If this is same only if it is 1 column. If you are selecting only 1 column. Right? Next. Wrapper embedded methods like lasso, bagging techniques, and boosting techniques. This is after modeling. Now, whereas wrapper methods, what is meant by wrapper methods? Wrapper methods means forward future elimination, backward future elimination, recursive future elimination. 3 techniques we are having. What is meant by forward future elimination? Forward future elimination means you are eliminating one by one unimportant variable in the in the order of whatever the beta quotients are there, right? Quotients, beta 1, beta 2. This is applicable only for regression. This is applicable for only for regression. This is not applicable for the classification. For classification algorithms, embedded methods we will apply. For regression problems, we will go with the forward, backward, or recursive. Okay. 99% of the cases will not even apply this one. Before that filter and after that we'll apply the future embedded. Generally will not go with this one. Okay. Now what is this forward elimination means? For example, we are having beta 1, beta 2, beta 3, beta 4. You are having like this 4 beta values. Out of which, whichever the beta is very low, that first you delete that variable and consider remaining 3. Out of again 3, again one of them will be low. Again remove that one. Whichever is low, whether it is second one or third one, whatever it is, remove the next least beta value. After that, remove with the least beta value. Like that, you continue till you get the single variable. That is called as forward future elimination. One by one, you are eliminating and you are seeing how the data is there. Sir, for example, beta 1, beta 2, beta 3, beta 4. That is 4 variables are there. That is x1, x2, x3, x4. You are having 4 variables, x1, x2, x3, x4. Or simply you say like this, or only 3 variables. Let us take simple example, 3 variables. Where we are having this one, TV, radio, newspaper. Now out of these 3, beta 3 is very low, assume. First you drop this one. Now you work only on these 2. And you calculate the R square. And after that, again you remove whichever the low beta is there. Again you calculate the R square. If the R square is changing too much, then you consider whatever the latest one is there. If the R square is not changing much, then you have to continue with the variables. This is called as forward future elimination. Backward future elimination means the beta values, whichever is having high values, that one we are going to remove. That is called as backward elimination. One is forward elimination, one is backward elimination. Best values you are removing and you are coming with the least value. Every time you will check the R square values. After removing one variable, again you will check the R square. After removing one variable, again you will check the R square. Again removing, again R square. Again removing, again R square. Okay. And next we are having the recursive future elimination. Recursive future means randomly selecting the variables. Random selection of variables. For all of them, we are having the codes. Don't worry. Shortcut is available. Code is available. Okay. So if you apply the forward future means automatically it will not tell it and it will not tell us which are the important features. For backwards elimination and for this one, everything code is available. The concept I am explaining. Right? Random selection. It is going to select randomly and it is going to remove the unimportant variables. One variable randomly it will be selected and it will remove and it will check the R square. Again, randomly it will remove one variable. Again, it will check the R square. Right? This it is going to do the random selection in order to reduce the overfitting problem. Sir, why we are doing all this random? Whenever the word of random comes into picture, you have to remember why we are going with random is we no need to have the bias. For example, now time is 8:40. Within 5 minutes at 8:45, I'm going to take the mock entry. Assume, example. I'm not going to take example only. Okay, example that I'm going to take a mock entry at 8:45. One student I'm going to select randomly from this class. I may choose last bench, last person. Right? Now, who is hiding? Right? I may select that person. Assume, example. Now, this one is bias. I am fixed that person. I am focusing on that person. He is hiding from last few minutes. So, I am focusing on that person. So, this is called as bias. Without using that one, if I am using the np.random.sample, so np.random.integer, randint, okay, and I am selecting one of the number, and that person I am entering is, I am not biased, right? In this case, there is no bias. In that case, there is bias. I am focusing on one person. That is bias. Whether I am interested in that person or whether I am anti of that person, that is secondary. But I am focusing on one person. That is bias. So when you are going with random, what is the problem? There is no probability of biasness. Completely randomly you are going to select. So in order to eliminate the bias, this kind of things they have created to eliminate the bias. Whereas in this case, you are deleting the important variables you are identifying and you are deleting one by one, right? So whereas this one is purely unbiased one, right? Is that clear? All this comes under future selection techniques. And next, we are having next concept called as future extraction method. The future extraction method is called as principal component analysis. Okay, where we are going to extract the information and then we are going to remove that variable, use and throw, right? So principal component analysis is the future extraction method. This is also used for dimension reduction. So this is one of the method where we are going to work. This is called as future extraction method, where it is completely creating a new futures. For example, 1, 2, 3, 4, 5. These are the original futures. Out of which, by removing one of the future, directly we are not removing. We are transferring the data to others. Okay. For example, you are having certain knowledge. You are having a knowledge of data science knowledge. You are having 70% knowledge you are having. Now, other person has transferred his knowledge. Now they have given to you a new knowledge, adding 10% of the new knowledge. Now you have got 80% knowledge. The original data you also has changed, right? I have removed the person and at the same time you have also changed. Here all the futures are going to transform into new variables. Okay. Here directly we are not going to identify the unimportant variable and we are not going to delete. This is not that concept. We are converting other futures also. Other futures also will be transformed. Completely they are going to be transformed. For example, here 11 futures are there. 11 input futures are there. 11 input futures are there. From 11 to 8 futures I have brought. Only 8 futures, 3 futures I have removed. Now, sir, which 3 futures you have removed, miss? I can't say the answer. Because that 3 futures was transformed into this one. The 3 futures has transformed their data to this 8 futures. Now the original 8 futures are also changed off. None of them is original one. All the 11 futures has been changed off. Okay. So now whatever from one person, I am transferring the data to another person. After transferring this one, the previous person, the knowledge is equal to 0. Okay. So for example, let us take, you are having one person. You are using that person for 60% usage you are having. Now, whatever the 60% usage of his is there, you are transferring that one to others. Now, what is the use of this person is 0%. There is no use of this person. Whatever this person can do, others also can do the same. This person, we are not having any use. Simply remove that one. Before it is an important. Now you have transferred the data. So this is called as future extraction. Future extraction method will transform the data without losing the information. that will lose the information, this without losing the information. Okay, sir, whether we are going to apply the feature selection or whether we are going to apply this PCA or whether we are going to apply the embedded, we are going to apply all of them. Each and everything we are going to apply, each and everything we'll try, and which gives the better answer that we are going to fix, and furtherly we are going to continue on the same. Whatever the machine was trained, whichever the which process has given you the better results, that process will be used in the real life. Right? For example, let us take this example. There is a Infosys share price. Infosys share price like this is there. Something graph is there. You have analyzed on your own way. Okay. Based on your analysis, whatever the analysis you have done. Okay. Whether it is a statistical analysis, whether it is a fluke analysis or whatever it is. Okay. Your analysis is working. Assume it is working. Now in the future also, I am going to use your analysis only, right? Since it is working now. If it is a failed one, I will not use. If it is a successful one, I will continue with your analysis. Sir, whenever you see a graph like this suddenly top, immediately there will be a fall, sir. Whenever there is a height of this much height, suddenly one day this much of height, the graph has increased, means remember immediately the next day there will be a drop. You have observed the same thing last 10 years, the same thing was happened. You have identified this pattern. Okay, you have told me. And whenever in the future data, whenever there is one more time, for example, on January 2nd, suddenly the price was increased like this. On January 3rd, what I'm going to do? It is going to reduce. And according to that, I'm going to plan. Whatever the previous analysis you have done, based on that, if it is working, miss, the same thing I'm going to use in the future. For example, your analysis is not working, then what is the use of your analysis? So in the machine learning, whatever the way you have executed for your training purpose, which algorithm you have used or which process you have maintained, and finally you have got the best accuracy, that process they are going to use in the real life also. In the deployment also, they are going to use the same process, because using that process, we got the best accuracy. Using that process, we have got the best accuracy, means real life also will have the same thing. Because here the process, we have checked the best accuracy not on the trained data, right? We have checked on the test data. That too, the test data was not given to the machine. Trained test split is a separate. Both are mutually exclusive data sets. They are not having any relation. So the test data you have already tested with some records. Unknown data you have already tested. For unknown data only, it has already predicted the best values. Means future data is also unknown. For that one also, it will predict automatically best only, right? Is that clear? For example, in this class, I have trained you. And in the mock interviews, I am testing you. In the test mock interview, I am asking a new questions which was not discussed in the class. Which was not discussed in the class, I am asking some questions. You are able to say the answers. Completely unknown data for you. You don't know that one. I have not discussed in the class. You have learned on your own. You are able to solve that one, and in the mock interview, you are able to answer on the test data, which is a completely new question also you are able to answer. Now, obviously in the real time in the company interviews also you'll answer, right? If I am checking only my questions, miss, and you are perfect only on my questions, miss, then it is called as overfitting problem. But in the mock interview, I'm going to ask you a completely new questions also, which was not discussed in the class. That scenario I have not discussed in the class, or that particular problem I have not discussed in the class also, I will ask you in the class only. You have answered correctly, then what happens in the real-time interviews also? Automatically your performance is very nice. Simple, same logic will be applied here. Right? In the machine learning, whatever the process we have done and for which we have got the best accuracy, that process we are going to use for deployment purpose. Which process has given me the best answer? From the starting to ending, one process will be there, right? The entire process which has given me the best answer, that I am going to use for my deployment and in the future data. Which process has given me the wrong result, that process I am going to delete. Simple. Is that clear? Right? So we are going to continue this one in the next class along with the coding part of the future selection techniques. Already you know the coding part. Everything you know, that is decision trees and lasso regression, everything you know. Just I have to show you only the wrapper methods code. Variance code you know. Information gain code you know. Whatever the chi-square test or one proportion test code you know, everything you know. Only wrapper methods code you don't know. So wrapper methods code I'm going to show you, and along with that PCA I'm going to explain in the next class. In the next class we are going to complete the entire future selection process. Once the future selection process means before the modeling and after the modeling, with that entire supervised machine learning will be completed. Okay, in the next class the entire machine learning, supervised machine learning will be completed. Actually, tomorrow, if there is a class, means it is a good one. But already we have declared as holiday, right? Yesterday only we have already declared that one. Okay, no problem. Okay, on Monday. Okay, on the Monday, we are going to continue with the PCA, that is future selection along with the future extraction. These two techniques we are going to apply on the Monday. And once the Monday class is completed, immediately we are moving on to the deep learning of ANN. That is artificial intelligence. On Tuesday class, we are going to move on to the artificial intelligence. Why, sir? Unsupervised machine learning you have not covered now. But in the artificial intelligence, ANN is there, right? The neural networks, artificial neural networks, that also used for regression and classification. Now, the same order, whatever you are following, immediately if you learn the ANN will be easy. In between, if you learn the unsupervised machine learning, again, you have to recollect yourself when we are explaining the artificial intelligence. Now, if we are saying like this, at the time, you'll see in a different way. Do you remember in the starting days, I told you if you don't practice, it is going to be some kind of Korean movie, something like this. At that time, you have laughed, right? Now you're understanding that one. If you don't practice every day, whatever we are discussing, if you don't remember the things, the next level of steps will be automatically more complex only. If you practice every day on the same day, and if you remember, and if you try to do the multiple times revision in between, the concepts will be very clear. Data science is not the subject. By listening itself, you'll understand everything. This is not that type of subject. Just by sitting in the class, seeing at the whiteboard and listening with your ears, completing as data science course and becoming as data scientist is never possible in your entire life. In the dream also it is possible unless you are the CEO. In the dream also you'll get as a data scientist job if you are the CEO. If you are not the CEO, means you'll not even get the job in the dream also. Right? For the data science, from the day one, we have to practice, and that too, everything are connected. Now the regression and classification, just now we have completed, right? Now the same concept we are going to apply in the artificial neural networks. Artificial neural networks is equal to regression and classification. Convolution neural networks, if you understand ANN, ANN is for regression and classification. This is used for regression and classification purpose. If you understand ANN, CNN is easy because NN is already covered, right? Only I have to explain the C word. CNN is easy. If the CNN is easy, CNN is working on the images. If images are easy, automatically video is easy. CV will be easy. These three are connected to each other. If you learn this one, this will be easy. If you learn this one, this will be easy. Right? Unsupervised machine learning is not having any connection with this sequential order. There is no connection.